Jntuh. In this class, I am going to discuss with the various multi-threading concept, multi-programming, and threading issues. Before moving to the topic, these are all the contents which we are going to discuss now. Multi-threaded programming, threads, different classification of threads, multi-threading model, threaded libraries, and threading issues. Before moving to the topic, what is a thread? Thread is a sequential flow of tasks within a process. The thread in OS can be same or of different types. Each thread has its own program, counter, stack, and a set of register. But the thread in a single process might share the same code, and it is also be termed as a lightweight process. So this is an example for a multi-threaded server architecture. Whenever a client is making a request to the particular server, the server is busy, means it will resume to the listening position of on waiting for the particular client additional requests, or otherwise it will forward the particular request and create a new service, and the thread will be accompanied with that. These are all the advantages of thread. The threads are more responsiveness, as we know that multi-threading concept is an parallel execution. An interactive application may be created, and it is allowed to use by the number of programs, and the programs being used by the different number of users along the world. Even it is a lengthy operation, it is capable of performing and blocking the particular sequence by increasing the responsiveness of the user. Then the second strategy is a resource sharing. The threads will share the memory and share the resources of the process to which they belong. The benefits of this sharing, it will allow the data to one particular application in which several addresses can be modified into a space. It is highly economic one. Allocating the memory and the resources for the particular process creation, it is not that much costly. It is very economical to create a context switch thread. The benefits of the multi-threading is another capability of increasing the multiprocessor architecture is the scalability process. That is nothing but running the process in a parallel manner. The next concept is multi-threaded programming. As we know that thread is a parallel execution. It is a basic unit of CPU utilization. It comprises of thread ID, program counter, register set, and a stack. With this, it will share the process within the particular application. Here, the code section, data section, and other operating system resources are effectively used. This is used for open a file and signals a file. It performs a task. A traditional thread will be of a lightweight process. In some cases, it will be a heavyweight process. If a process has a multiple thread of control, it can capable of perform a one or more task at a time. So this is an example diagram for a single thread process and a multi-thread process. Consider this diagram. These are the different sections of a thread: code section, data section, file section, registers, and stack. This is an example for a single threaded process. While in a multi-threaded process, it is classified into code, registers, and stack, data, registers, and stack, file, registers, and stack. Coming to the next topic, multi-threading model, it is classified into user thread and kernel thread. User thread is nothing but the kernel that are managed without the help of a kernel is called as a user thread. Kernel thread is directly operated by the operating system. There are three types of relationship are there: many-to-one model, one-to-one model, and many-to-many model. The many-to-one model uses the threads to one kernel. This can be explained with the help of this diagram. Here, many-to-one model, many user threads are created and it is connected to the single kernel. The example for this model is a Solaris. One-to-one model, here one user thread is created to the single kernel. So these are the applications which are directly connected to the sequence. Here in the one-to-one model, it provides concurrency by allowing more than one thread into the process. The next process is many-to-many model. Here, many modes of multiplexes and multi-users are being used that may be equal or smaller to the particular kernel thread. So this can be explained with the help of this diagram. Here, the number of user threads are more compared to the kernel. It will allow the developer to create more user thread as it run in a parallel application. The next topic is multi-core programming. As we know that multi-threaded programming and multi-core programming are comparatively similar. Both will be running the application in a parallel mode. It is classified into 5 different areas: dividing activities, balance, data splitting, data dependency, testing, and debugging. Dividing activities, this involves examining the application to find the areas that will be divided and parallel, including the different types of sequence. The balance, which is identify the tasks that can be run in a parallel. The programmer must ensure that the tasks are equally performing their particular work. While in the data splitting, the applications are equally divided into separate tasks and the data accessed are manipulated by that particular task. Data dependency is nothing but the data is accessed by the particular task and it can be examined for how many number of dependencies between the more number of tasks. Testing and the debugging, when the program is running in a parallel and a multiple core, there are different execution paths are there. The concurrent program is inherently more difficult. Moving to the next one, threaded libraries. Threaded libraries can be implemented either in a user space or in a kernel space. The first approach is to provide the user level library function in a user space without the help of the kernel support. The second approach is to implement a kernel level library supported directly by the operating system. 3 main threaded libraries used today are POSIX, pthread, Windows 32, and Java. POSIX threads are used for the extension of the POSIX standard, which may be provided both the user level and the kernel level library function. Window thread library is a kernel level library which is available on the Windows. Java thread, which allows the API to be created and managed directly into the Java program. Moving to the pthreads. The first classification is POSIX thread. It refers to the POSIX standard IEEE 1003.1 C standard, which defining an API for the thread creation and synchronization. Here, the 2 functions are created. One is a main function, another one is a runner. Both were created and control the threads. A set of attributes and the parameters are used in this type of functions. For example, we can say that Linux, Mac, Solaris are the functions which are used in this type of application. Coming to the next topic, that is Windows thread. These threads are created with the help of Windows API using the create thread function. Here, a set of attributes and the parameters are used. Security information is a major concern. Java threads are the more important feature in a Java language that the API has a set of features for thread creation and management. All the Java programs contains a single thread of control. Only in the main method of function, a single thread used in a Java machine. Here, we can create a thread in 2 ways. One approach is to create a new class that is derived from a thread class and override that particular function. An alternative method is to define a class and run in an interface. So this is a Java method. First, we start a method by creating a new object. It will dynamically run and initialize the memory. This method is called as a runnable method. Public interface runnable. We are going to create a run method directly in this file. Next one is threading issues. As we know that threads can be parallelly run in a multi-threaded environment. Several issues were faced in the thread while creating the fork and the execution system called signal handling, thread cancellation, thread local storage, scheduler activation. Like that, these are the issues in the thread. Moving to the first one, that is thread creation, that is fork and execution system call. The fork on the process, which we are going to create a new process that is not a duplicate one. In some of the Unix system, fork system call are created. It is limited to the specific frequency range. In the other operating system that is for Windows, that is not able to create the fork system call. Moving to the next one, that is signal handling. Here, the signal handling is an important concept in the threading issues. It is used only in the Unix operating system. The signal that may be received is signal synchronously or asynchronously, depending upon the source of the particular event that is going to be generated. A signal is generated by the occurrence of a particular event. The signal is derived to a process. Once it is delivered, the signal must be handled. The other issue is the signals are always delivered to a particular process. Delivering the signal will meet to the signal applies, or it may be delivered the signal to the every thread that is existing in a process. The next important issue is a thread cancellation. If multiple threads are running parallelly throughout the database, the threads return the result and the remaining thread might be cancelled. Here, all the threads will be loaded into the pages and it can be derived sequentially. Here in the thread cancellation, we can use another technology that is called as, depending upon the resources, we use the deferred cancellation method. Once a thread is indicate that the target thread is to be cancellated, but the cancellation will not be occurs only when the target thread has checked a flag to determine whether it is a cancelled or not. This allows a thread to check whether the particular object is going to be cancelled at a point or it going to be safely in another sequence. Another important feature of a threading issue is a TLS concept, that is thread local storage concept. It is a process which belongs and share the data to the particular process. It is easy to use this TLS with the local variable and with the function invocation. Another important issue of a threading is a scheduler activity. A final concept of the thread multi-threaded programming concerns and communication will be takes place between the program by using the multi-threaded concept, that is user thread library, and the kernel is known as the scheduler activation. How it is going to be work? As we know that thread is a lightweight process. This is a one-to-one correspondence between the lightweight process and the kernel thread. The number of kernel threads are available here dynamically. The application maps the user thread and go to the lightweight process. Thank you.